In this section, we're going to look at the fundamental counting principle. Now, the fundamental counting principle, let's read about it. It says if you can choose one item from a group of M items and a second item from a group of N items, then the total number of two-item choices would be M times N. Okay, so let's put it in an example that has to do with outfits. This is a tree diagram. Okay, there are two different pair of pants, blue and black. And there are three different color of shirts, gray, yellow, and blue. And you want to know how many outfits you have. Well, you say, how many pair of pants do I have? 2. How many shirts do I have? 3. That means 2 times 3 is 6. And I'm going to have 6 different combinations of pants and shirts to wear. And this is an example of that. On example 1, applying the fundamental counting principle. The Greasy Spoon restaurant offers 6 appetizers and 14 main courses. In how many ways can a person order a 2-course meal? Well, we have a choice of 6 appetizers, 14 courses, so we would do 6 times 14, and the answer would be 84. There are 84 different ways to enjoy that 2-course meal. Let's look at this one. Okay, we're going to talk about the number of ways it's possible to do a series of successive things. Okay, so not just 2 groups, but more than 2 groups. So we want to know the number of possible outfits from 2 pairs of jeans, 3 t-shirts, and 2 pairs of sneakers. Okay, so here's our tree diagram for each jean, each shirt, and the 2 pair of sneakers. You can see at the end we have 12. All you have to do is multiply your 2 pair of jeans times your 3 t-shirts times your 2 pair of sneakers. 2 times 3 times 2 does give you 12 different outfits. The next one talks about the options for planning a college course schedule. Next semester you are planning to take 3 courses, math, English, and humanities. There are 8 sections of math, 5 of English, and 4 of humanities that you can find suitable. Assuming no scheduling conflicts occur, how many different 3-course schedules are possible? Well, you multiply the 8 times the 5 times the 4, and you get 160 different schedules possible. How about a multiple choice test? It says you're taking a multiple choice test that has 10 questions. Each of the questions has 4 answer choices with 1 correct answer per question. If you select one of these 4 choices for each question and leave nothing blank, in how many ways can you answer the questions? This one is a little bit different because you have 10 separate questions and each question has 4 choices, okay? So it would be 4 times 4 times 4 times 4 times 4. You want to do that 10 times, which is basically 4 to the 10th power. And there are 1,048,576 different ways you can answer those questions. Let's talk about telephone numbers. Now, we use digits for telephone numbers. There are 10 digits. Anytime you see the word digit, you want to think of 10. Okay, there are 10 digits. And that is because we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's 10 digits. Now, it says that we have a 3-digit area code followed by 7-digit local numbers. Area codes and local numbers cannot begin with 0 or 1. How many different numbers are possible? Okay, so here's my 3-digit area code. My first choice, I can only have 8. I can't include 0 and 1. I can only do 2, 3, 4, 5, 6, 7, 8, 9. There's 8 of them. Now for the next 2 numbers in the area code, I can pick from all 10. For my local number, my first blank, I can't use a 0 or 1, so I can only use 8. And for all of the rest of the numbers, I can use all 10 digits. So it's going to be 8 times 10 times 10 times 8 times 10 times 10 times 10 times 10 times 10 times 10. And we end up with 6,400,000,000 different possibilities.